class, in this section, in this chapter, we're going to be focusing a lot on gases and pressure. So for today's lesson, we're just going to kind of introduce you to the idea of gases and their common properties and the idea of pressure and how to calculate it. So as a little introduction to gases, a lot of this is going to sound familiar because we have talked about this in chemistry and we've also kind of hit on it a little bit in integrated science. Gases can exist as both elements and compounds. In their element form, they can exist in two different states, monoatomic versus diatomic. And these elements that we're talking about that exist as gases do so at ordinary conditions such as ordinary temperature and pressure. Now when I say ordinary temperatures, I'm talking about room temp. Now onto the two states. Monoatomic elements that are gases are going to be things like helium, neon, argon, krypton, xenon, and radon. You're going to notice all of these elements tend to be noble gases. Noble gases exist in group AA on your periodic table. In other words, it's the group on the far right. Like we said, these are monoatomic, meaning one atom. If you remember from chemistry, noble gases tend to be very unreactive because they have a full octet, so it should make sense that they exist as a single atom. Other elements on the periodic table that are gases at room temp are going to be things like hydrogen, nitrogen, oxygen, fluorine, and chlorine. These are said to exist in a state called diatomic. Di means two, atomic means atoms. So these are going to be things that are reactive, so they either want to bond to themselves, like we see here, or they do bond with other elements to form compounds, because many compounds are also gases. Typically, these compounds are going to be composed entirely of non-metallic elements, and all that means is they do not have metals in them. So compounds that are going to be gases typically are going to be formed from nonmetals and metalloids. If you remember back to chemistry, we called these compounds molecular compounds. So down below I have a few examples like carbon monoxide, carbon dioxide, ammonia, etc. Now, I also want to make the distinction between gases versus vapors. Usually these two words are used interchangeably, but they do have distinct meanings. When I say gases, these are going to be things under ordinary conditions, and when I say vapors, these are substances that are typically liquid or solid at room temp, but you can heat them up to become a gas. The most common one that you guys have probably heard of is water. We don't call it water gas, we call it water vapor. It's because water is a liquid at room temperature, but you can heat it up to form a gas. So let's talk about some characteristics of gases. One thing to note is that many gases have different chemical properties. So for example, some gases are flammable and some gases aren't. Some are really reactive and others aren't. But they do share a lot of similar physical properties. Some physical properties that gases share is that they are said to have no definite volume and no definite shape, which means they are going to expand spontaneously to fill both the volume and shape of its container. The other thing is that atoms in gases are going to be spaced relatively far apart. So these atoms are not close together, they're constantly moving far apart from one another, and that makes gases highly compressible. And that all that means is that if you apply a pressure to a gas, we can decrease that volume between those atoms and fit them into smaller things. For example, you've probably heard of helium tanks. That is compressed helium gas. Oxygen tanks, we have compressed oxygen into a smaller volume for us to use. And lastly, these gases are going to be very fast-moving particles that are constantly moving in very random movements. Now let's go off of gases and move on to pressure. What exactly is pressure? Pressure is defined as the amount of force applied over an area, or we use the equation pressure equals force divided by area. Hopefully you guys remember from your math class, but area, if we're going to talk about just standard area, is length times width for a rectangle, or square. Obviously, there are more complicated ones, but we're going to focus on just the simplified version. And force is a push or pull on an object. Now, gases are going to exert a pressure on any surface they come in contact with because of their mass and gravity pulling down on them. So you've probably heard of atmospheric pressure. This is just the force that the atmospheric gas exerts on the surface area of the ground or on us. So atmospheric pressure at sea level is about 101 kilopascals, or 1.01325 times 10 to the 5th Pascal, or PA. Now, it's a couple things to understand pressure. Based on our formula, we have to know both force and area if we're going to calculate pressure. And we have to understand how these variables are related. Force and pressure are actually directly related, which just means that if you increase the force, the pressure should also increase as long as the area doesn't change, and vice versa. So if you decrease the force, the pressure should also decrease. The other aspect is area and pressure. These are going to be inversely related, and all that means if one goes up, the other goes down. So if you increase the area, and the pressure is going to decrease as long as the force applied is constant. This brings into the idea of, should you be cutting vegetables with a sharp knife versus a dull knife? You want to use a sharp knife because you have a smaller surface area. Therefore, you don't have to require as much force in order to cut through the vegetable. Now, with units. The SI unit for pressure in science is called the Pascal, or we abbreviate it as capital P, lowercase a. And all Pascal stands for is 1 Newton per meter squared. Just like any unit in science, that is not the only unit that you can use. You can also measure pressure in bars. The one you're probably have heard of is pounds per square inch, which is PSI. That is typically what tires register pressure in. So if you have, let's say, a 32 PSI tire, atmospheres, millimeters of mercury, and torrs are other common units that you can use. Just like with anything in science, not everything is going to be given in the same units, so we need to be able to convert these units. Gas pressures are going to have to be converted from, for example, ATMs into PSI. Or we might have to convert torr into bars. So all of these conversions that I have down here are equal to one another. So for example, 1.01325 bars is going to be equal to 14.7 psi. And so we can use them as conversion factors to convert between one unit and another. I will give these to you on your test, and you will be given these on your homework as well. You just have to know how to use them. So we're going to walk through 3 practice problems to end our lesson. Our first practice problem says we're going to convert 0.357 ATM to torr. Just like any conversion, you are going to start with what you are given. So here you are given 0.357 ATM. Just like we did first semester, in order to use a conversion, we need to cancel out what we're given. So here we're given ATM, so to cancel it, we have to put that on the bottom. The top is going to be what we're trying to get to. So it's asking us to get to our torr. Now we have to go back and look what was the relationship between ATM and torr. So if we go back, we have 1 ATM equals 760 torr. So that means 1 ATM is going to go here, and then 760 torr is going to go on top. Also note, if the number is on top, we are going to multiply. If the number is on bottom, we are going to divide. So here we can take 0.357 times 760, and you're going to get 271.32. Based on sig figs, we are going to actually have 3, so I'm going to say this is 271 torrs. Now let's look at the second example. If you want, you can try to pause this video and try it on yourself to see if you're getting a hang of it, and then you can unpause it and see if you get the correct answer. So just like the last problem, we're given a value, 26.7 psi. You're going to start conversions with the value you're given. Then we're going to have to set up our conversion. Here we're starting with psi, so we need to cancel it. We're going to put that on bottom. And it says we're trying to get to atmospheres, so that's what we're going to put on top. Again, you're going to have to go back and check to see what that relationship is. And here it says 1 atm is equal to 14.7 psi. So 1 atm is equal to 14.7 psi. Again, notice this number is now on bottom, so we're going to have to divide 26.7 divided by 14.7. And you should get the value 1.816326.531. I'm going to keep 3 sig figs based on my beginning number, so I'm going to round this to 1.82. Again, my unit, never leave numbers without units, and this is atm. Our last example, again, you can pause this and try for it. I wanted to throw this last example in here because right now we've been working with a number where it's like 1 atm. But what if there are 2 numbers here? So we have 147.2 kilopascals. Okay, that's what I start with. We're going to set up our conversion. We want to get rid of kilopascals and go to torr. Again, we have to go back to the previous slide and look at this relationship. Torr is 760. So we're going to fill that in. Kilopascal is 101.325. Notice here that both of these numbers, there's a number on top and there's a number on bottom. And so when you throw this in the calculator, you're going to take 147.2 times 760, and then you're going to divide it by the 101.325 since it's on bottom. When you do this, you get 1,104.090797. We're going to keep 4 sig figs, so 1104. Torr would be our final answer. And that's the end of today's lesson. If you have any questions, please make sure that you ask, and I hope you guys have a great day.